Griffiths E&M Problem 523. Goal of Problem 523 is to find the magnetic vector potential of a finite wire carrying current I, and they recommend to put our wire on the z-axis from some point z1 to some other point z2. Okay, and it says to use equation 566, which tells us to calculate the magnetic vector potential by integrating over the current path, 1 over script r dl prime. Okay, so this is the z-axis, this is the x-axis, and this is the y-axis. And I want to do this integral and find the magnetic vector potential at some random point in space, which will have coordinates x, y, z. Okay. I see a script r down there, so I need to build my script r vector. Script r starts by building r. That is x, x hat, y, y hat, z, z hat. My r prime vector points to some chunk of my current. That is z prime and z hat. And then my script r vector, it's not script r. Script r becomes x, x hat plus y, y hat plus z minus z prime, z hat. And I don't actually need the vector, I just need the magnitude of that. That becomes square root of x squared plus y squared plus z minus z prime squared, all under the square root. And I see that I can call x squared plus y squared r squared. Okay, great. Next thing I need to do is to figure out, so I figured out 1 over script r, alright, I have script r, and now I need dl prime. That's the path along the wire, which is dz prime in the z hat direction. Oh, great, now we have all we need to do. Script r, or script a, vector, it's not script a, that's just a vector, 1 over 4 pi. I'm going to do the integral of 1 over script r magnitude, which is r squared plus z minus z prime squared, times dz prime z hat, and my bounds are going to be over the pieces of z prime that have wire on them, so that's from z1 to z2. All right, I can do that integral. I plug that into my online calculator. I either get hyperbolic tangents, inverse hyperbolic tangents, or logs. I've chosen to pick the inverse hyperbolic tangent solution because it's a little bit cleaner, at least up front. So that becomes mu naught over 4 pi tang inverse of z prime minus z over z minus z prime squared plus r squared, evaluated from z1 to z2 in the z hat direction. All right, and you plug those in. I'm not gonna do that. There you go. That's what the magnetic vector potential is from a finite wire.